Good morning. Today I'd like us to start to think about what is the connection between multiplying decimals and multiplying fractions, and how are they the same and how are they different? Because we already know how to multiply decimals, so we want to try to extend that to multiplying fractions and see if some of the strategies might be similar. Okay, so I'm going to come over here. So just say we wanted to think about an expression like 2/3 of 4. When we see 2/3 times 4, it means 2/3 of 4. And when we see 4 times 2/3, it means 4 groups of 2/3. So this is the commutative property being modeled right here. We say these in a different way, and that kind of helps us think about different story situations, like I spent 2/3 of my $4, or I traveled 2/3 of my 4-mile trip. Whereas here we might think about, I have 4 jars of sauce, and 2/3 of them, I have 4 jars, and they are filled with 2/3 of a cup in each jar, right? Or I have to run around a track 4 whole entire times, and the length of the track is 2/3 long, okay? So we're gonna think in a few different ways here, okay? Now, you might think about 4 holes like this, 4 whole candy bars. And if your friend came along and ate 2/3 of all 4 of your candy bars, you might think about cutting all of your candy bars into thirds, and then saying, well, my friend, I don't know, he must really like candy bars, and maybe have different types. Here's 2/3 of a Kit Kat, here's 2/3 of my Snickers, here's 2/3 of my Twix, and here's 2/3 of my, I don't know, Almond Joy. Anyway, my friend ate 2/3 of all of the candy bars that I had. I had 4 candy bars. 2/3 of 4, if I count all the thirds that I have here, 1, 2, 3, 4, 5, 6, 7 thirds, 8 thirds. So 2/3 of 4 equals 8 thirds. So many of us might really be thinking about each whole as its own individual whole, but I'm going to push you to think about all of the holes in one bar instead, okay? So let's look at this situation, okay? There are 33 students in class 5-3, and 2/3 of them like tacos. Now, I don't know this for sure. Let's just pretend that that's true, okay? So in 33 students in class 5-3, 2/3 of them like tacos. We've encountered a lot of fraction problems where the whole was just one whole class. Now we know the value that this one whole entire class is 33 students, okay? And if 2/3 of them like tacos, well, I could think about each third of my class individually. 1/3 would be 11 students, another third would be another 11 students, and another third would be another 11 students. And we know that 2/3 of class 5-3 like tacos, which means that 2/3 of 33 is 11 students plus another 11 students, 22 students like tacos. Okay, so in this way, we just used one bar to represent a whole, divided that whole into equal parts, and we can tell how many parts we need by looking at the denominator, and then the numerator tells us how many of those equal parts we need, okay? Now, if we're thinking about a different situation, okay, there are 48 pies at the bakery, 2/8 of them. Here the numerator is the same, denominator is different, okay? 8, oh my gosh, I'm gonna have to cut this bar up into 8 equal pieces. So there are 48 pies at the bakery, 2/8 of them are blueberry pies. So I know my whole is 48. I'm going to divide this into, let's see, fourths, eighths. Now, if I divide 48 into 8 equal pieces, the value of each piece should be 6, right? 6 times 8 equals 48. And 2/8 of those pies were blueberry. Okay, so you can see now 2/8 is so much smaller than 2/3, right? Because the pieces of eighths are smaller. So 2/8 of 48 equals 12. 12 pies. Now you might be noticing that every time we multiply a whole number by a fraction, the product becomes much smaller. So today's strategy that we're working on, and what I would like you to work on, is to make a bar model to represent one whole, and then to think about the size of that whole. So we're going to think about the problem here, 1/4 of 36. Okay, so step 1 is to make the bar and know what it represents. So right here, our whole is 36. Okay, we're going to divide that bar into equal parts by looking at the denominator. It'll tell us how many equal parts we need. Okay, and then we're going to divide our whole into the equal parts, kind of separate them out. I know that if I divide 36 into 4 equal parts, the value of each part will be 9. And then when I look at the numerator, it will tell me how many of those equal parts I need. I just need 1 equal part in this case, 9. So 1/4 of 36 equals 9. Okay, so just to reiterate the steps again, you're going to make the bar, know what it represents, divide the bar into equal parts represented by the denominator and the fraction, divide your whole equally between each part, 36 divided by fourths, we get 9, and calculate the amount of parts you need based on the numerator. I wrote that wrong, okay? So as you can see here, if I had 1/4 of 36, that would make 9. 2/4 of 36 would be 9 plus 9, 18. 3/4 of 36 would make 27. And 4/4 of 36, well, that would be all of the 36. 1 times 36 is 36, right? I hope this video helped you today to learn something new, or at least a new way of modeling it. If you already know how to multiply fractions, this might be something a little different for you to try out today. So try it out. The problems that you're going to solve today are linked to your assignment. When you're finished with today's assignment, please take a photo and link it to the assignment at the end. Have a great day. If you want any help with anything that you learned here today, you can come to the drop-in meeting at 11 a.m. Tuesdays, Wednesdays, Thursdays, and Fridays for any support that you might need. Have a great day.